Teacher Carlos Plain of Durham School states, "Totally, I went through my entire time on Earth empowering an express hypothesis of the universe. Additionally, at last, the hypothesis is being tried. I invite that, since that is the means by which we push ahead. That is the manner by which we gain ground in science. The James Webb Space Telescope is upsetting a remarkable measure of what has been seen as truth in cosmology. For the new year, another ultra-deep picture shows that we have serious mistakes in cosmology. The telescope, which was intended to show us the essential stars of the universe, is changing into an enemy of the past perspective and may present us with a thoroughly astonishing science. Not all experts are developing in dread at the new real factors. Other well-informed specialists welcome the progression since it has, for a genuinely long time, been sure that something was the matter with our old speculation. The deviation in the assessment of the progression speed of the universe alone should have shaken specialists' discernment in the past. Yet, bringing everything into account, they stuck to old theories. The galactic microwave background radiation, CMB, considered the most settled light in the universe, was made something like 380,000 years after the Big Explosion, right when the universe had cooled enough for electrons and protons to form stable hydrogen particles. Researchers call this interaction reionization, which made the universe transparent to light. The CMB was first seen in 1964 by American physicists Arno Penzias and Robert Wilson while they were dealing with another kind of radio-receiving antenna technology. This discovery was, for a really long time, seen as possibly the most grounded piece of proof for the hypothesis of the old Big Bang, procuring Penzias and Wilson a Nobel Prize and an evident spot in the history of stargazing. The CMB in all probability offers a viewpoint on the early universe with little temperature contrasts, giving fundamental data about the conditions not long after the Large Bang. Experts included the CMB as a solid scratching of the fundamental assessments of the material universe to check the progression speed of the universe, in addition to other things. The cosmologist Edwin Hubble had already settled this in the late 1920s, tracking down that faraway world's retreat from us and that their speed is relative to their distance. Today, these perceptions are known as the Hubble regulation or the Hubble constant. Hubble didn't have the high-level evaluating methodologies available many years after the fact, at the point when the CMB was found, which prompted a recalculated development rate. These were, by and large, lower than Hubble's original figure. Later, experts recalculated the rate again utilizing type Ia cosmic explosions as standard candles, giving stable light that could be used as a solid measuring point. The assessments inside the CMB yielded an extension speed of around 67 kilometers per second per megaparsec, while estimates utilizing grandiose blasts yielded around 74 kilometers per second per megaparsec. What does this dissimilarity in deciding the advancement speed of the universe truly tell us? Did you sort out that this goof has been known since the 1990s? Since that point, inspectors have known, or at least felt, that something may be the matter with the examination of the CMB, the appraisal techniques, or the possibility of the universe's extension. The anomaly between the SAW and expected upsides of the extension rate is alluded to in science as the SAA pressure or Hubble strain. The ramifications of this strain are gigantic, showing that fundamental bits of how we comprehend the universe may be deficient. For a seriously lengthy time, specialists were puzzled. Since the James Webb Space Telescope went into action, it has outfitted experts with stunning information that may now uncover data on the issue of the improvement speed of the universe. With systems so old and mature that their improvement should have begun hypothetically before the Big Bang, upsetting old cosmology, specialists never again discuss mistakes or evaluation contrasts. They discuss the emergency in current stargazing. Not exclusively could the improvement rate be off-kilter, but the entire idea of development or the Big Bang itself is being called into question. Pictures from the telescope give proof of a universe completely unforeseen from what we have long thought. The SAA pressure was the chief reproach to specialists who still have confidence in old speculation. Now they manage an issue. Do we, in fact, grasp the universe? Different researchers stand on the remaining parts of their once brilliant wellspring of both revelation and torment, exploring space with fear and wrestling with what they find. Taking into account the emergency in science, we should ask ourselves, what do we, in fact, have some experience with the universe? To answer this, we truly need to get a handle on how science functions. Theoretical experts utilize a complex game plan of mathematical models, wary information, and keen reasoning to move ends from the general to the specific. Their understanding comes from a blend of discernment, credits, significant outcomes, and speculative appraisals. The term theory alone shows that these are advancements and considerations, not through and through bits of information. The primary critical data we have are the photographs telescopes give, the sound waves and radiation accumulated with radio telescopes, and the most recent information from neutrino studying systems or gravitational wave pointers. With the James Webb Space Telescope, we presently have an instrument that can part the light into person frequencies and break down it in noteworthy ways. Webb can show us the essential pieces of systems in the early universe billions of years ago, how much mass they contained, and the quantity of stars present. Can also follow the shape and course of a world's improvement. Webb, anyway, has impediments. For example, it can't continually totally decide whether we are seeing worlds or, on the other hand, black holes with enormous gravitational powers that produce as brilliantly as a system. We should face the truth that our science has long acknowledged an over-the-top number of potential results as realities while excusing elective clarifications. Research has, for quite a while, been certain about its accuracy. The most recent disclosures from the James Webb Space Telescope are fundamental signs to supplant theories with new experiences, as has occurred for the most part in science. Examiners are excitedly expecting the new disclosures, which are unexpectedly surprising, and different specialists are endeavoring to develop new clarifications. The new disclosures shake the underpinnings of our ongoing science, disturbing numerous specialists. The current models of veritable science are still generally founded on Isaac Newton's regulations from the 17th century. His laws of movement and gravity were the groundwork of our cognizance of the truth of this world and the universe for quite a while. Newton's standards get a handle on the develop me. Don't yet fathom. One thought is that the genuine properties of dim matter and dull energy have changed over time, perhaps showing some type of advancement. Gravity is one more hypothesis to be tried. This power, which makes fascination through mass or arch in spacetime, has not yet been completely made sense of. The concepts of spacetime shape, which begin from Einstein and have been generally upheld, may require returning to. We can't excuse the likelihood that gravity has unanticipated properties or that another force is liable for the gravitational fascination between objects. After some time, a couple of constants have been laid out in cosmology and stargazing as all-inclusive standards. The investigation of the universe has forever been an excursion characterized by our steady quest for understanding and disclosure, from antiquated human civilizations noticing the stars to current space telescopes investigating the profundities of the universe. Each move toward improvement and hypothesis has uncovered new insider facts while testing laid-out convictions. In the area of cosmology, the James Webb Space Telescope, JWST, remains as a guide of our logical advancement, promising to change how we decipher the universe's starting points and advancement. Sent off with exceptional abilities, JWST addresses a jump forward in observational space science, intended to look further into the universe than at any other time, with extraordinary accuracy in examining radiation. The CMB, frequently alluded to as the shine of the Big Bang, offers a viewpoint on the universe as it existed just a short time after its first communication with the world. This antiquated type of radiation conveys fundamental data about the universe's initial circumstances, including its temperature varieties, which are critical to understanding the improvement of systems and huge scope structures. The divergence in the decided likely upsides of the Hubble constant, known as the Hubble strain, has been a subject of drawn-out banter. It suggests that something is off with our fundamental comprehension of the universe and its initial organizations. Revelations challenge conventional speculations and call for a reassessment of whether our point of view on infinite improvement is essentially defective. New bits of knowledge may reveal stowed-away pieces of the universe's creation, bringing up questions about dim matter and dim energy, two unexplained parts that make up the vast majority of the real world. The headway of science relies upon the capacity to reshape our hypotheses in view of new data. Webb's mission encapsulates this pursuit. Its disclosures will act as a foundation for future cosmological conversations and ought to light new viewpoints on the universe's secrets. The eventual fate of cosmology might observe tremendous changes, prompting significant suggestions for how we decipher the universe, from the Big Bang to the continuous cycles that characterize its destiny. The reply to the best limitless inquiry may lie past our ongoing information, and Webb's perceptions may eventually be fundamental in revealing new bits of knowledge that could reshape how we decipher reality itself. The way forward for cosmology and space science is filled with expected discoveries. Each groundbreaking perception and piece of information from telescopes like Webb carries us closer to noting the most significant inquiries mankind has ever presented. How did the universe start? What is its definitive destiny? Are there different structures of life out there? Or are we alone in this huge universe? These are questions that may one day track down answers, and the James Webb Space Telescope is at the forefront of this fantastic exertion. The fate of cosmology will probably involve a combination of new innovations, refined hypotheses, and historic disclosures that keep on pushing the limits of what we know as we venture further into the obscure. One thing is sure, science, like the actual universe, is consistently in a condition of consistent development, driven by the quest for information, getting it, and the marvel of revelation. The realm of cosmology is presently at a critical point, where well-established speculations are being addressed and new information is provoking a reassessment of the universe's starting points. As the James Webb Space Telescope keeps on delivering weighty experiences, the logical community is confronted with the undertaking of reworking hundreds of years of information. What we assumed we comprehended about the universe is currently during the time spent being toppled, recommending that our past models and suppositions could have been inadequate or imperfect. Webb's extraordinary capacity to analyze the far-off compasses of room has opened up a world of probability unlike any other instrument before it. Webb's infrared vision permits it to look through the thick infinite residue mists that frequently darken our perspective on the universe's most far-off objects. By catching light from probably the earliest universes, Webb is giving a brief look into when the universe was simply starting to take shape, well before the Earth, the Sun, or indeed even the Milky Way existed. These disclosures are fundamental for grasping not just how systems shaped, but also how the first stars ignited, which will have significant suggestions for how we might interpret heavenly advancement and the overall development of the universe. As researchers continue to analyze Webb's information, they are faced with a large host of new inquiries. For example, the telescope has uncovered cosmic systems that appear to have developed a lot quicker than previously thought, challenging current models of cosmic system arrangement. These discoveries suggest that the pace of cosmic system development may have been much higher in the early universe, requiring a reassessment of the cycles that govern the development of systems. Moreover, Webb's perceptions have uncovered that the conveyance of matter in the early universe may not be as uniform as once suspected. This new knowledge could significantly modify our comprehension of the huge scope construction of the universe, requiring new hypothetical models to make sense of how worlds and other inestimable designs framed and advanced. Webb is additionally offering new points of view on dim matter and dim energy, two of the most slippery and secretive parts of the universe. These two peculiarities make up roughly 95% of the universe's complete mass-energy content, yet they remain generally unexplained. While dim matter is accepted to represent the gravitational impacts that can't be credited to noticeable matter, dim energy is believed to be answerable for the sped-up development of the universe. Webb's perceptions could provide basic signs that might help researchers better understand these confounding powers and their role in the universe's evolution. One more critical area of research that Webb is adding to is the investigation of exoplanets. Researchers are at a junction.